Hi to all, welcome back to my channel. This is KVS, a mentor for CBSE, JEE Mains and Advanced, and also for all other competitive exams. In this video, I would like to bring one of the best example, one of the best model for growth, and decay. So it is geometric progression or geometric sequence. So without late, I would like to bring some of the interesting and important points in geometric progression. So first of all, I would like to give the definition of a sequence, the geometric sequence, a sequence of terms where each term is found by multiplying the previous term by a constant term. So previous term is multiplied with always some constant term. That constant term is called common ratio. So usually denoted by small r. Small r is the common ratio. This is the key term in GP. Example, if the common ratio is r is equal to 3, r is equal to 3 means for growth, and r is equal to 1 by 2 less than 1. So this is meant for decreasing or decay. So usually the terms in GP, whenever first term is given, first term is A, whose first term is A, and a common ratio CR is some R is given. CR is some R. First one is A. So multiplying with R, you get the second term AR. And the third one is A into R square, A into R power 3, and so forth, So if you want to generalize to find the last term, nth term will be equals to, nth term T suffix n is equal A into R to the power n minus 1. So this is the first formula we have to use in the sums. So here is one example based on the last term. So find the last term. You're asked to find out what is the last term in the given sequence. Sequence is given by first one is 1, next one is 1 by 2, and rising faster 1 by 4, 1 by 8, and 1 by 16, and 1 by 16, 1 by 32, and so forth. So terms are decreasing very fast. So that means we can conclude they are in GP. So first term is here k is equal to 1, and common ratio you can take the T2 by T1 here. So therefore k is equal to 1, R is equal to T2 by T1. So 1 by 4 by 1 by 2, or 1 by 2 by 1. If I go with first two terms means 1 by 2 by 1. So common ratio will be 1 by 2. So therefore term n will be equals to 1 into 1 by 2 to the power n minus 1, or you can say 1 by 2 whole power n minus 1. So this is one example for term last. So second important one is sum to n terms of GP, sum of n terms of GP. So that is nothing but S sub n, S suffix n. Okay. So S suffix n is nothing but, so sum of all n terms, first one is A plus A into R, and k into R squared plus and so forth, A into R to the power n minus 2, and the last one is A into R to the power n minus 1. So this sum I want to find out. So whenever growth model is given, whatever the common here, common ratio is R, multiply both sides with common ratio, left hand side it becomes R into Sn. So in the right side what we do, leave the first term and place the resulting terms in second term onwards, from this term onwards. If I subtract here, so this term gets cancelled, A left here, and this will become A into R to the power. This will changes to A into R to the power n. So finally what I am going to get here, Sn is equal to, sum to n is equal to A into 1 minus, this is the sum of the n terms, not the last term here, 1 minus R to the power n divided with 1 minus R. So this is used when common ratio is fractional quantity, minus 1 to plus 1 here. And if R is above 1, the sum can be taken as A into R to the power n minus 1 by R minus 1 if R is greater to 1. You can use any formula at any time, but generally if you want to differentiate, if the fraction is given, 1 minus is better, and if more than 1 is given or less than minus 1, so this sum we can use here, right? Suppose in case of exactly R is equal to 1, R is equal to 1 means you can't apply this formula, directly you are getting the sum will be equals to n times of A, So some more interesting things in GP, we will see in the next class. So thank you for your supporting. Sorry. One more example is there here. So based on the sum to n terms here. So the sum of the terms is given by s is equal to 1 plus 2 squared and 2 power 3 and 2 power 4 here. So by observation, we can see that here terms are rising very faster. That means growth model is given up to n terms. We can go with any number of terms here. So by common sense, we can say a is equal to 1 and the common ratio will be equals to 2 here. A is the first term, R is the 2 here. Therefore, if you want to find term n means directly a into r power n minus 1, a into r to the power n minus 1 to find the last term of a sequence. And if you want to find the sum to n will be equals to 1, a is 1, r means 2 to the power n minus 1 by 2 minus 1. So therefore, sum to n will be nothing but 2 to the power n minus 1, 2 to the power n minus 1. This is the sum to the n terms. Suppose n is 1 means sum is only 1. N is 2 means the sum is 3. Like you can see here, 1 plus 2, sum is 3 here. Right? By observation also you can find the last term. So this is a perfect example for growth model. So thank you for your support, and in the next class I will bring the remaining and also important things in geometry. Thank you so much.